All right, we're back to wrap up our special segments in triangles unit, and we're going to do that by talking about an altitude. Altitude, really just a fancy word for height. We've worked with that before. Um, but let's take a look at it. So, an altitude, by definition, will go from a vertex perpendicular to the line containing the opposite side. Now, that language makes it sound a little tricky, but it isn't. Think about it from the vertex perpendicular to the opposite side. So the blue line here is the altitude or the height of the triangle. Now, why does it have to have that language, the line containing the opposite side? If you guys think back to probably elementary, but definitely middle school, you've seen triangles. Remember when you're trying to do like area equals 1/2 base times height. And sometimes when that's the triangle, but you're shown the height on the outside, well, altitude is fancy word for height. So sometimes that altitude or height is drawn outside the triangle. And notice how we kind of had to extend the line of the triangle. That's what we're saying here. It has to be perpendicular to the line that contains the opposite side of the triangle. So don't let the words trip you up. You've seen this 100 times before. Now, here it is again. An altitude can appear outside the triangle. It only happens with an obtuse triangle. We also want to recognize that in a right triangle, both legs fit the definition of an altitude. So we can think of our altitude right here from the vertex perpendicular to the opposite side. But technically, technically the other leg fits the definition also, vertex perpendicular to the opposite side. It really just depends on how the triangle is rotated. The way the triangle is drawn right now, most of us would think of the red segment as the altitude. But if I rotated it, then most of us would think of that blue one as the altitude and the red one as the base of it, of the triangle. So sometimes it depends on just perspective and the way the picture is drawn, but they both fit the definition. Altitude from the vertex perpendicular to the opposite side. Sometimes it's outside the triangle. Like the others, a triangle could have 3 altitudes drawn, and the point of concurrency where they intersect is called the orthocenter. So if we draw all of the altitudes in, that point of intersection is called the orthocenter. Again, just some vocabulary. Now, here's an interesting point. In an isosceles triangle, that segment drawn into it fits all the definitions. Well, 4 of them. It does not fit a mid segment, but it is a perpendicular bisector because it's perpendicular and it bisects. It's an angle bisector because it bisects the vertex angle. It's a median because it comes from a vertex to the midpoint of the opposite side. And it's an altitude because it's vertex perpendicular to the opposite side. So each term has its own definition, but sometimes a segment fits more than one definition. And we always want to make that observation. Okay, we always want to make that observation. Let's take a look at an example or two. We're told AB is an altitude. By definition, this must be perpendicular. which means this must equal 90 degrees. So x equals 20. They didn't show us the little right angle box. They didn't tell us that they're perpendicular, but they told us it's an altitude. An altitude must be perpendicular. Perpendicular means it's a right angle. Right angle means it measures 90. There are multiple definitions being used here, and we have to know all of them. In our next question, we actually drew this triangle in the previous lesson. I'm just going to redraw it. A is at negative 2, 6. B is at 3, 0. C is at negative 3, negative 4. In our previous lesson, we were told AD is a median. So if you remember, we found point D. So we found point D by doing midpoint formula. And we found D to be at 0, negative 2. So what's the new piece here? We're going to determine if AD is an altitude, which means is AD perpendicular to CB? And altitude has to go from a vertex perpendicular to the opposite side. Well, it's going vertex to opposite side. Question is it perpendicular? How can we determine if these segments are perpendicular? We're going to test their slope. So we want the slope of AD and the slope of BC, or CB. Same thing, doesn't matter. Same segment. So we're going to use our slope formula. So have your formula sheets handy for things. Testing AD. Y2 minus Y1. X2 minus X1. So it looks like negative 8 over 2 or negative 4. Testing, finding the slope of CB. Y2 minus Y1. X2 minus X1. It looks like 4 over 6 for 2/3. Perpendicular is when they have opposite reciprocal slopes. So this is not true. Not perpendicular. Not an altitude. Now we could count points. We could also count it. We didn't have to use slope formula, but it's not always going to be perfectly on that grid. So make sure that you have your slope formula available to you and you're ready to use it. Determine if AD is an altitude is a fancy way of saying, is it perpendicular? How do we tell if it's perpendicular? We test the slope. Okay. So there we go. We have our altitude. And that wraps up our special right triangles. Do a little more practice with it to wrap up the unit.